Bismillahirrahmanirrahim. Assalamu alaikum. Mathematics first year, chapter number 4. Today we will talk about geometric sequence. What is geometric sequence? In a geometric sequence, each term is found by multiplying the previous term by a constant. Like 1, 2, 4, 8, 16, 32 and so on. Now look at this. This is a geometric sequence because if 1 is the first term, then 1 is multiplied by 2, we get 2. And 2 is multiplied by 2, we get 4. And 4 is multiplied by 2, we get 8. And 8 is multiplied by 2, we get 16. And similarly the processes go on. Now what is 2? Here 2 is a fixed constant number. So it is the definition of geometric sequence that when a term is multiplied by a constant number, the sequence so obtained is called a geometric sequence. This sequence has a factor of 2 between each number. Each term except the first term is found by multiplying the previous term by 2. So it is a geometric sequence. Look at the rail line, which is from 0 to up to 16 positive real numbers. Look at 1. 1 is multiplied by 2, we get 2. Similarly 2 is multiplied by 2, we get 4. And 4 is multiplied by 2, we get 8. And 8 is multiplied by 2, we get 16. And so on. If 16 is multiplied by 2, we get 32. And we will get a sequence like 1, 2, 4, 8, 16, 32 and so on. So this is a type of geometric sequence. In general, we write a geometric sequence like this. Look at the terms. In the braces, the first term is A, the second term is AR because there is common ratio. R is called common ratio, which is multiplied with A, we get AR. Now multiply AR with R again, we get AR square. And similarly multiply AR square with R again, we get AR cube, and the process is go on, where A is the first term and R is the factor between the terms called the common ratio. Here A is the first term, which is called A1, and R is the factor which we have multiplied with the first term, then the second term and so on. We get the geometric sequence. Example 1, 2, 4, 8. It is a type of geometric sequence. The sequence starts at 1 and doubles each time. So A1 is the first term. R equal to 2, the common ratio between terms is a doubling. When we double the first one, we get 2. 2 is double 8. 2 is double 4. 4 is double 8. 8 is double 16 and so on. So it is a geometric sequence. And we get the general term. If we compare these 1, 2, 4, 8 with these, so A1 is A1 is 1, AR is 2, AR square is 4, AR cube is 8 and so on. Look at this. A1 is 1. Now 1 cross AR. Look at this. The second term is AR. Now since A is 1 and R is 2, we have do this as R equal to 2. Then the next term will be AR square and AR cube. By simplifying these, we get 1, 2, 4, 8 and so on. This is a geometric sequence. But be careful, R should not be 0. Yes, remember students that R cannot be 0. What's the reason that why R cannot be 0? Because when R is equal to 0, we get the sequence A, 0, 0 and so on, which is not geometric. Because there is no constant number which we multiply with the term, we get the next change number. Also, if we calculate the common ratio, the common ratio will be infinity, which is undefined. So the terms of the geometric sequence cannot be 0. Rules. We can also calculate any term using the rule. Look at the formula. This is the formula for the init term, called the init term of the geometric sequence. That is, an is equal to ARn minus 1. Here an is the init term A is the first term, R is the common ratio, and N is the number of term. We use N minus 1 because A R 0 is for the first term. Why we take N minus 1? Because because that the first term, which is A, there is no R. So A R 0 is the first term. That's why we are going to take N minus 1. Where R equal to A2 by A1, A3 by A2, A4 by A3, and so on. In general, we can write An divided by An minus 1. That is, the upper part of the ratio will be greater than 1 with the lower part. Look at another example. 10, 30, 90, 270, 810, 2430, and so on. This is also a geometric sequence. This sequence has a factor of 3 because each number, the value of A and R. Look at this. This is the first term is 10. The second will be 10 multiplied 3, which is 30. The third term is 90 because 30 multiplied 3 is a factor of 3. So A is the first term, which is 10, and R equal to, we know the formula that R equal to A2 over A1, second term divided by first term. After simplification we will get 3, the common ratio. The rule for any term is, as we know that the general term An is equal to ARn minus 1. So comparing this formula with the above sequence, we get An is equal to, look at, A is the first term, which is 10. 10 multiply R is the common ratio we have calculated here, and N is the number of terms. So this is the rule for the above example. Now by putting N equal to different values, like look at this, we want to calculate the fourth term. The fourth term is 270. By putting N equal to 4, look at this, the fourth term is A4, we'll get 270, which is exactly in the example. The fourth term is 270. And the 10th term, if we want to calculate the 10th term, we just put N equal to 10 in the rules. Look at this, A10, 10 cross 3, 10 minus 1. After simplification we will get 19, 68, 30. So this is the 10th term of the geometric sequence. A geometric sequence can also have smaller and smaller values. Dear students, remember that a geometric sequence can also have a smaller common ratio. It is not necessary that the common ratio will always be greater than 1. It may be smaller. It cannot be 0. Example, look at this, 4, 2, 1, 0.5, 0.25, and so on. Look at this. This is an example of geometric sequence with a common ratio. This sequence has a factor of 0.5, a half between each number. It has a common ratio 1 over 2, which is equal to 0.5. Why geometric sequence? No, this is an important question. Why we call geometric sequence as a geometric sequence? Because it is like increasing the dimensions in geometry. Because look at the sentence that it is like increasing the dimensions in geometry. If we take R equal to the first one, R, simple line. A line is one dimension and has a length of R. Now if we multiply R with R, we get R square. So this becomes a square shape, which is in 2 dimension. A square has an area of R square. And if we multiply R square again with R, we will get a 3D figure like cube. A cube has volume R cube, etc. Yes, we can have 4 and more dimensions in mathematics. Remember this, in mathematics we have more dimensions. Note, geometric sequences are sometimes called geometric progressions. Dear students, remember that geometric sequences are also called geometric progression. We will discuss later, inshallah, that there are 3 types of progressions, that is arithmetic progressions, geometric progressions, and harmonic progression. Why? Because the 3 are satisfied different and specific rules. That's why we called geometric sequence geometric progression